So because we have really limited time, can someone type in the chat for me, when is paper one exam? You should know by now, when is paper one, BJC paper one exam? Okay, so you see that we really have a short time, technically 5 weeks maybe. So what I'm going to do is we are going to focus on some of the heavy topics at the beginning, and then dwindling down to the end, we will then go and pick up some of the paper one topics. But for now, we'll focus heavily on the paper two topics. Okay? So we're going to start today with the distance time graph. This is a paper two topic. I need you to, and I don't know if you can use your math book that you use in school. So if you have an extra book, you can go ahead and you need to take some notes today, yes. Or you can start from the back of your math book. So let's do that. Our topic today is the distance time graph. We're going to start with you taking some notes, and then we're going to go into the BJC booklet. Now, I don't know if some of you would have your BJC booklets with you, but if not, there's a site called Student Shared that we're going to use today. So what are distance time graphs? Distance time graph, and I'm going to send this link in the chat, okay? So if you don't get to write it all down, you can always go back and write it down. That's the link for this page. So distance time graph are graphs that show the distance of an object or a person who has traveled against time. So every day we travel against time, because when we walk to school, we're traveling against time. So as simple as you getting up, going to the kitchen, you're applying the distance time graph. You are traveling against time, and that's what distance time graph is. And sometimes we call it a travel graph. That's what you may know it as. A distance time graph will show the distance in meters, kilometers, or miles. Now, when we talk about the distance, and I'm going to explain the graph before we start working, it is actually showing your distance on your vertical line. Let me make this a bit. So my vertical line, everyone knows what a vertical line is. It will be the line that runs from north to south. That's your vertical line. So with the distance time graph, your distance, which is how many steps you make, or how many miles you travel, that would be considered your distance. So it is your movement. So your distance would be on your vertical line, your up and down. And this is normally to the left of your graph. And you can see with this particular example, our distance is covered in miles. Now, our horizontal line, which runs from west to east or east to west, calculates our time. How long did it take us to get from our bedroom to the kitchen? How long did it take us to walk from home to school? How long did it take us to drive from our home to the grocery store? So the time is calculated along the horizontal line. So two things you need to remember. Your distance is going to be to the left, and it's calculated in either miles, kilomiles, meters, and your time is going to be at the bottom, which is the horizontal line. Okay, let's go back to the notes. Also, our vertical line is also called our y-axis. And if you did graphs before, linear graphs, if you did that before, then you would know how to draw and label our X and Y axis. So this would be considered my Y axis, and my horizontal line is considered my X axis. Something else I need to explain before we move on. Straight line on the distance time graph represents a constant speed. So if you're looking here, you notice that at 0 and at 12 o'clock, there is a constant flow of movement. So for instance, James started here, and if he's walking along, there's no stop. That means there's no stop. But when you see a flat line or a horizontal line, that means that this person is taking a break or rest. That is your rest period. And if we continue, then the person starts to walk again. Then we can see that there's a rest period here again. And then the person is returning home. Okay? So when I'm moving up, I've left whatever, for instance, my home. I've left my home. I took a break, probably for a drink, and then I continue my journey. I took another break, and then I'm returning home. Okay? So what do you need to know? You need to know that the flat lines are your rest periods. When the line is consistently moving, that means that the person is in a constant speed of movement. Okay? So I'm going to give you a few minutes. I want you to take some notes, please. I'm going to highlight. I also want you to draw. So let's do this as quickly as we can. And then we're going to go to the practice questions. I want you to take this down. Only what I highlighted is what you're taking down. And this also. Once you are done taking it down, everyone, you give me a thumbs up so that we can move on, please. Okay, so I see one hand is complete. I'm going to move on in a few more minutes. Let's see, 2 persons. So I need you to get a ruler and a pencil. Now you're going to draw as best as you can. Just a basic. Now this doesn't have to be perfect, okay? When you draw this doesn't have to be perfect. I just need you to go ahead and draw a L. Your distance is at the left. Your time is your horizontal line at the bottom. So I just need to put time, just put time here at the bottom. Put distance at your left. You don't need to go ahead and put these numbers in. Time, distance, just go ahead and draw movement, stationary period, movement again. So this is my flat line that shows that I'm not moving. We have to know this. Not moving. Wherever you see a flat line, that means that you're not going anywhere. Wherever you see a steep line, that means that the person is moving. There is a speed going on. So not moving, you won't be moving here, but here you're returning home. Let me put that in as well. Okay, once you have that, we're going to move on. Those persons who are just coming in, I send the link in the chat. I'll resend it. And this is the sheet that we're working from, what you're seeing on the screen. And let's see if we can be here on time. Please. I'm going to start right away. And everyone, I hope everyone is signed up for the exam if you're in here. But this is BJC, and which will then be somewhat of the BGCSE core. Okay, 2 more minutes. So this is how a BJC paper 2 question will look on time graph. So the question says the graph below represents a bicycle ride from Smith's Bend to River Rock. Again, at 0, that means that the person is still here at Smith's Bend. River Rock is here. So the person is leaving on a bicycle ride from Smith's Bend and they're stopping here at River Rock. Remember I said the distance will always be to your left, and in this time the distance is calculated in kilomiles or kilometers. Kilometers it is. At the bottom, this is the time the person took or left Smith's Bend and end at River Rock. Can someone tell me, or raise your hand first, what time did this person leave Smith Bend? Once you raise your hand, I'll let you know. James. That's a hand raised, James. Or Diane Russell. Okay, so James said 7 a.m. That's correct. So the person left at 7 a.m. What time did that person arrive at River Rock? So we can see here, 0. The person is leaving at 7 a.m. That's when the movement starts. What time did they arrive at River Rock? 12 noon. Good. Because 12 noon is where the movement ends. There's a stop. And you can see that he remained at River Rock. He didn't return back home. So at 12 noon, he arrived. Okay. In total, this is my distance. That's 0. And you can see that we're skipping. So 0, 20, 40, 60, 80, which means between 0 and 20, we will have 10. There's a half mark there of 10. So on the BJC, you would put these things in. Do not go ahead and start the questions without completing the graph itself. So let's complete the distance. So 0, 10, 20, 30. And if you don't have a BJC booklet, I said earlier that this is on Student Shared. This is BJC Paper 2, 2018. So 0, 10, 20, 30, 40, 50, 60, 70, 80. The distance is normally easy to calculate, to complete. But now let's go to the time. The time is at the bottom. It doesn't say time, but you can see that it's 7 a.m., 8 a.m., so you know that that's calculated in time. So we have 7, 8 o'clock, 9 o'clock, 10 o'clock, 11 o'clock, 12 o'clock. What goes between 7 a.m. and 8 a.m.? What is the midpoint between 7 a.m. and 8 a.m.? Good, I see it, 7:30. So we're going to complete it all together, 7:30. So please, on your exam, use these strategies. Complete the clock, complete the distance, complete the time before you begin. So this will be 10:30. This will be 11:30. And then we have 12 noon. Okay, now my next question is this. Since this is 7 a.m. and this is 7:30, this is 8 a.m. and 8:30, can you tell me, each box is calculated in how much intervals? What is the amount that each box weighs? If we started at 7, and then we went to 7:30, then we went to 8, then we went to 8:30. Each box, good. Each box, I see it, good, Deshane and James. Each box is calculated in 30 minutes interval. We need to know that also. So each box represents 30 minutes. So we can put from here, starting from 0 to this end, that's 30 minutes. Each box is 30 minutes, okay? Each box represents 30 minutes. Okay, so now we've calculated that. Now, the only thing is now, when I shift up, everything is going to shift. So let's answer the first question. We completed our time graph. Now we're going to answer the question. A says, at what time did the cyclist make his first stop after leaving Smith's Bend? Remember, what did I say a stop is? How would you recognize a stop? You would recognize a stop by a flat line. Good. Or Kaden said the dent in the line. Yes, but I said you would recognize the stop by the flat line. So where are my stops? My stops would be here. This would be another rest period or another stop. Okay, so the question says, at what time did the cyclist make its first stop? From the beginning of my stop, I'm going to come down. So I saw the answers in the chat. Yes, the first stop was at 8:30. So that's my first answer. Let's see if everyone can pull up the sheet on student shared, please. Let's do that. If you can, let's go to student shared. BJC Math 2018. You're going to see the sheet. Scroll down to paper 2. I'm going to make this smaller so we can see all of the questions. But let me know when I make this smaller if it's a problem for you seeing it too big. So that I can see all of the questions one time. Okay, so 8:30 would have gone here. I'll come to the last question afterwards. So 8:30, he made his first stop at 8:30. Right here. This is his first stop, and the beginning of the first stop starts here on 8:30. Good. Let's calculate the total time the cyclist stopped all together. How many stops did this person make? Okay, if you can't find it, just watch my screen for a minute. Okay, so this is my first stop. Remember earlier, we calculated the intervals for each box represents 30 minutes. So that's 30 minutes. Again, we have another 30 minutes. We have another 30 minutes. So if we calculate 30 minutes and 30 minutes and another 30 minutes, how many minutes is that? And then we'll calculate it in hours. So 30 minutes and 30 minutes will give me 60 minutes. Another 30 minutes would give me 90 minutes, right? So this person stopped altogether for 90 minutes. 90 minutes. But how many minutes is in 1 hour? Okay, so we have 90 minutes. We know that 60 minutes is in 1 hour. So if I subtract 60, I'm left with 30 minutes. So therefore, this person stopped for 1 hour and 30 minutes. If you put 90 minutes, that is correct. If you put 1 hour and 30 minutes, that is also correct. Any one of you the correct answer. Let's go on to the next question. The next question says, how many meters? Oh my God. Does the website say that the class starts at 9 o'clock? Someone answer me in the chat. Because a lot of students are just coming in now, which is so late. Okay, so how many kilometers away from River Rock was the cyclist at 10:30? First thing we're going to do is we are going to go to 10:30. And we are going to mark it. At 10:30 is here. The question is asking how many kilometers away from River Rock, okay, was the cyclist at 10:30. Now remember, River Rock is here. This is River Rock. It's asking us how many kilometers away is this point. So the person is here. How many kilometers away is the person from River Rock? So now remember where our kilometers is. Our kilometers is on our left side because that is the distance. Each box going up, we saw that it was what? 10, right? So if the person is here and we're trying to move here, we have to count each box going up now, not across, up. So from here, that's 1. And if we go up again, there he would be to River Rock. So how many kilometers is that? Let me see persons in the chat. Good, I see it. I see the answer. Good, that's correct. Good, so if we count, remember now, we're not moving across because across represents time. But up and down represents our distance. So if each box represents 10, or I would not say each box, each point represents 10. If we start from here and we enter River Rock, that will be from here, going up, that's 10, 20. So from 10:30, he was 20 km away. And you see all of these work 1 point. So you're not working really hard, but you have to understand what you're doing. What is the distance between Smith Bend and River Rock? I'm going to give you some time to work that out. Five. So what is the distance between Smith Bend and River Rock? Okay, the distance between Smith Bend and River Rock. So Smith Bend is here and River Rock ends here, but we're calculating the distance. So we need to count upwards. So make your 2 points on the line because you want Smith Bend, which is your start, and River Rock, which is your end. But you're calculating the distance. Count upwards. So this will be 10, 20, 30, 40, 50, 60, 70. So what is the distance between Smith Bend and River Rock? It would be Mr. Rich, what's her name? Richina. Don't write on my screen, please. I didn't tell you to write on my screen. Don't do it. It would be 70 km. And then the last question, it deals with a formula. So I'm going to give, but I just want to make sure everyone is flowing with me. If you have a question, send it to me in the chat, please. Okay. It says, how long did the journey from Smith Bend to River Rock take? Excluding stops. That is very important. Excluding stops. So that means the stops is not wanted. It just wants the constant movement or the constant speed. So how long did the journey from Smith Bend to River Rock take? Excluding stops. So this is asking us for time now. So how long is the time that is asking? So it's asking how long. So we want, so my thing is this. When a question asks you to exclude time, what you can do is you can find the entire amount of time and subtract those stops. So you can find the entire amount of time taken and subtract those stops. So the question is asking us, how long did it take? We know including our stops, and I'm going to ask the question, you can answer. If you want to unmute, then you would just raise your hand first, because I don't want everyone shouting out one time. But the entire journey is taken, that's including stop, from 7 to 12. How many hours is that? That is including stops. You can type it in the chat, please, if you want. Or you can unmute after you raise your hand so that I can. So if this person here is moving from Smith Point to Smith Bend to River Rock, they left home 7 a.m. and they arrived 12 noon. How long did that take? And we can just add these. So that would be 1 hour, 2 hour, 3 hour, 4 hour, 5 hours. So that's 5 hours. But that is including stops. Now, what we can do, earlier we found that the total time the cyclist stopped was 1 hour and 30. So what we can do is we can subtract that hour and 30 minutes from, because the question says excluding stop. So if we subtract that hour and a half from 5 hours, this would be 1 hour. If we subtract 1 hour, then we are left with 4 hours. That's the 1 hour stop. If we go ahead now and subtract the 30 minutes, if I subtract 30 minutes, then I'm going to put the minutes in so that we can know that the conversion. So we subtract 30 minutes from 4 hours, then we're left with what? 3 hours and 30 minutes. So how long did the journey take, excluding stop, would be 3 hours and 30 minutes. And again, how did we find that? We had to find the total time taken from 7 a.m. to 12 noon. But because the question asks us to exclude stops, we have to subtract the stops. Now, the question would say include stops. Sometimes it does. Then you would just go with your 5 hours. Doesn't want the stops. So we would have to subtract those stops. Good. I see it. Ebony Cobra. Good. And then we have one more question on this page, and we go to another page. And I'm going to do that page because some persons are just coming in. So I'm going to do that page. We're going to do it together. And then I'm going to let you do one all by yourself, just so that I know you understand. So I'm going to shift up, which means that this will shift. So the last question would be, calculate the average speed of the journey. Again, it's a excluding stops. I'm going to write it on the side. So there's a special formula that is used to calculate speed. Does anyone know that the speed, DST, the distance speed time formula? If you know it, type in the chat. Calculate the average speed or just speed. Calculate the average speed of the journey, excluding stops. Okay, so someone says speed is distance over time. Now, I'm going to show you a little trick that I like to use. I just like to use a triangle because a triangle gives us all three of them. All three of the formula, you can just interchange this triangle or hide one. DST. Okay, so this is the formula. If you want to find distance, distance is equal to speed. I'm putting this dot here, represent multiplication. Distance is equal to speed times time. If you want to find time, you would cover time, and then time is equal to distance divided by speed. If you want to find speed, then speed is equal to distance divided by time. And I call this the DST formula, DST. And how you would remember it, you're going in order, or alphabetical order, D, then S, then T. Okay, so that's a formula that you can memorize, and you can use the triangle because it gives all in one. So instead of you memorizing, okay, distance is speed times time, speed is distance divided by time, time is distance divided by speed, you just use your triangle. This line here represents division, the line going up and down represents multiplication. So take that down for me, please. And then we're going to calculate the average speed. So this question is asking me to calculate the speed. The first thing I need to do is speed is equal to D over T. Distance divided by time. Take that down for me. Now, this question wants us to exclude our stops. So we don't want the stops. So what we're going to do is, and I find that this method is the easier method that I'm going to show you. What we can do is, we want distance over time. We can go ahead and calculate all of the distance and then divide it by the time. So before we do that, I have just something for you to read. I think this one is. Yeah. So this worksheet here that I send the link to in the chat, this has everything on it that you need to know. Right here. This is the question. So finding the average speed of the whole journey from the distance time graph. So if you're asking to find the average speed for the entire journey without excluding stops, the distance time graph shows the journey of a person that leaving home. I said that earlier. So let's go. This question is asking, what was the person average speed for the whole journey? So I just want to give you an idea of what you're doing first. So what we would do is, we would locate any relevant points from the graph. Yes, Beniqua.
You go read some written on the chat, please.
There you go. So we can see here, this was the first movement. The second movement is here. Well, here I should say. So the first movement would be 10, 20, which calculating the distance, we're calculating D. So that would be 20 km. The next movement is at this point going up. So that would be 10 km. From this point to that point, 20 to 30 would be 10 km. There it is. Next movement would be at this point. This is a return, but it's still moving. So from here to this point would be, that's 10, 20, 30. So the total distance was traveled, and in this you can see that this is excluding stops. The total distance that was traveled altogether would be the 20 plus the 10 from here to here, plus the 30 from this point returning. That will be my distance, which would be 20 plus 10 plus 30, which is 60 km. Then we will divide it by the total time taken. This would be from 0 to 3, which will be 3 hours. So when we divide it, the average speed is the total distance divided by total time. We're left with 20 kilometers per hour. Okay? So I find that that method is simpler. Now, if you were taught another method, that's fine. But this method, all you're doing is you're adding up all of the distance and you're dividing it by the total amount of hours. So let's go back to this paper now. So now this is what I want us to do. I want us to calculate all of the distance, the constant movements. And I want you to send that to me in the chat. So I'm going to just highlight the point. So from here to here, remember you're calculating the distance, not time yet. Time is just going to be the entire time. From here to here, that's another distance. And from here to here, I want someone to give me the total distance. You can send it in the chat or raise your hand. Remember, each box for distance represents 10 kilometers. Good. I want to see some more answers coming in. 2% so far. I want to see some more answers coming in. Be careful with your calculation. So this one would be, that's 10, 20. Then you would go from here. 10, 20, 30. Then you would go from here. Good. I see the answers coming in. Good. There's a lot of views. I'm waiting. Okay, I think that's enough. Good. So we see we got, I didn't calculate it, but I think it's 70. Majority of you said 70. So that's 20. So going up for those persons who didn't say anything, just be sure. So from this point to this point, remember, we are slanting, but what are we calculating? We're calculating the distance. So that's 10, 20, 20 in. Then another movement would be 10, 20, 30. And then another movement would be 10, 20. Good, so 70 it is. Okay, what is the total time taken? What is the total time taken here? Now, calculated on the horizontal line or the x-axis. So what is the total time taken? Good. Coming in. Keep them coming. Okay, yeah, so 5 is the answer. Okay, so now that we have our distance, which was 70, and our total time, which is 5 hours, what's my final answer? If I go ahead and divide 70 by 5, kilomiles per hour. That's it. Those persons who came in late, I know some of you had a challenge, but classes start at 9 a.m. We started exactly on time, probably about 9:06 or so, because I was waiting. So if you're just coming in, then that means you would have missed the introduction of this. I said I'm going to do another one just so that we can bring everyone up to speed, and then I'm going to let you do one all by yourself. Okay, so I think who's that asked me that question? The Johnson person? That's the answer to your question. Okay, so the next one, I think I had it here. Yeah. And all of these papers can be found on Student Shared. Once you click mathematics as a subject, and then you would click on the BJC, these are paper 2 questions. That was 2018 just now. We're on 2016. So with the BJC, now you may understand the topic and understand the concepts, but in class, your teacher may ask you it a different way. So even the questioning techniques with the BJC, you need to become familiarized with. Okay, so I think the first exam is May 31st, someone said. So we need to become familiarized with the question techniques as well. Because if you don't understand the question, then that can be a problem. Okay, so let's go with this one. Now, those persons who understand, you can just go right ahead and then we'll compare answers. But this question says the graph shows an athlete on a run from bridge M to bridge T and back. Remember at the very beginning, moving from 0 is that you're leaving from your original place. But when you see that there's a opposite direction going backwards, then that means that you're returning back to your original place. Of course, the person wouldn't run this way and then go back up. Okay, so now we're going to go ahead and first we are going to completely label our graph. Any missing line, any missing box, we're going to put the intervals in, we're going to put the time in, we're going to put the distance in completely. That's the first thing we do. So let's go ahead now and see how is the distance going up by. From 0 to 2, we're going up by 2. But between here, it has to be 1 because between 0 and 2 is 1. So we're going to complete this graph. 3, 4, 5, 6, 7, 8, 9, 10, 11. So we're going to complete the graph first. That's my distance. My time will always be at the bottom. So let's go. So from 0 to 11. Let's see how many boxes is between them. So that will be 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. This is 12. 1, 2, 3, 4. That's 1. 1, 2, 3, 4. That's 2 p.m. Let me make it just a tad bit bigger because it's small. Okay, that's the best I can do. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11. Okay, now we need to figure out how much does each one of this box represent. Okay, so between each hour, there are 4 boxes. Let me see who can tell me. If between each hour, there are 4 boxes, then what would be the value for one box?
20 minutes.
Let's check. Okay, so this is from here to here is 20, 40, 2, 4, 6, 8. Do you think it's 20? We have to get a full 100.
$25.
Okay, who agrees that it's 25? So let's do it this way. Let's do it this way. So we know that between 10 and 11, there must be a 10:30, right? Let's do it that way first. So I'm going to find my 10:30 first. So between them, which means at an even point, this would be 10:30, right? So that's 10:30, which is the half mark between 10 and 11. So what is the half mark between 10 and 10:30? What is the half mark between 10 and 10:30?
10:15.
10:15. Okay, I see it. I see the answers in the chat. Sorry, I didn't check the chat, but that is correct. So 10:15. Let me put that in. So this will be 10:15. This line here will be 10:30. So what will this line be here? If that's 10 o'clock and that's 10:15 and that's 10:30, what should this be here? 10 what? 10:45. It's a bit small. Let me see if I can. So that's 10:45. So you see, the first thing we need to do is we need to complete our graphs. Okay, and fill in the time. I find that filling in the time is easier than us trying to find, okay, what does each box represent? Once you fill in the time, then you will see what each box represents. So let's do that first rather than us filling the intervals first. So we have 11 o'clock, then we know that this is going to be 11:15, 11:30, 11:45. 12 o'clock, 12:15, 12:30, 12:45, 1 o'clock. 1 o'clock, 1:15, 1:30, 1:45, 2 p.m. Is that clear? Which means if we are moving up by 15, that means that each box represents what? 15 minutes. So 15, 30, 45, 60. So I was supposed to say we should complete a 60 because it's 60 minutes in an hour. So 15, 30, 45, 60. 15, 30, 45, 60. 15, 30, 45, 60. 15, 30, 45, 60. Okay, so the question say, how long does the athlete stop altogether? Now, some persons got this because you were here from the beginning. But I'm still going to explain. So the stops represent our flat spots or flat periods, which are rest. So how long does the athlete stop? So how long, that tells you the time. How far, it talks about distance. So how long, if each one of these boxes represents 15 minutes, then just add up your 15 minutes interval between all of the boxes and tell me. Now that's in hours, okay? So let's be careful. What you get? 1 hour, 1 hour, good. I see 1 hour, 1 hour. Let's see how those persons got 1 hour. So this is 15. This is 15 minutes. So 15 plus 15 is 30. Plus 15 plus another 15. So 15, 30, 45, 60. So that's 60 minutes. But the question is calling it for hours. We know that 60 minutes is equal to 1 hour. So your answer is 1 hour. Good job. Let's go to the next one. At what time does he arrive at Bridge T? At what time does he arrive at Bridge T? Remember now, he's at Bridge T. So where the movement stops is the time that he arrived. Where the movement is flat, then that means that he's just sitting at the bridge, doing whatever he wants to do. But we have to calculate from the peak of his stop, which is right here, right? So now, what time does he arrive at Bridge T? Okay, 12. So at Bridge T, which is there. If I were to come straight down, let's come straight down on the line, not between the line, not between the boxes, but on the line. What time did he arrive at Bridge T? Everyone sees that? So when the question asks us for the distance or the time, you would have to be on the whole lines. So that would be 12 noon. At what time does he arrive at rest stop B? Oh, okay. At what time does he arrive at rest stop B on the return home? Now that's a trick question. On the return run. At what time does he arrive at rest stop B? What time does he arrive at rest stop B? Now you have to calculate that because that's between. And if you have, now let me tell you, and this is why it's good to label this all together. Because if you had already labeled this, then you should be able to tell me exactly what it is, even without calculating. But if you don't at the very beginning label your graph completely, it's going to work you hard out at the end. So I'll give you some time. That's 11:15, 11:30. This would be 11:45. This is 12, 12:15. 12:30 is here. This would be 12:45. Okay, good. I see it. It says, what time did he arrive at stop B? What time did he arrive at stop B? Everybody get it? 12:45. Good. So he arrived at stop B at 12:45. So he rest stopped before he started returning home. So that would be stop B. Your arrival at stop B is here. So if I come down on the line, then he would have arrived at stop B at 12:45. Now the question says to calculate the total distance run. So let's calculate the total distance. I want you to calculate the total distance run. see one person so far. What is the total distance? Remember, this is your distance. What is the total distance? It didn't say anything about exclude, stops, and all of that stuff. So what is the total distance? Okay, I see it coming in now. Remember now, this person, unlike the last question we did, that person went to that place, but it didn't show where they returned. So the total distance would be up and and you're coming down. So that's a hint. So what is the total distance? Think about it. If you leave from home, you went to school, you leave from home, you went to school, and you came back home. So this person left Bridge M, went to Bridge T, and then returned back to Bridge M. So what do you think the total distance would be? First of all, the distance is only up to 12 km. So if he went up to 12 km and went back down to 0, what do you think the total distance is? I'll give you some more time. Listen, this question is not asking us for the average distance. It's just asking us for the total distance. Y'all overthinking this thing. Okay, I see someone got 48, someone got 28, someone got 24. Okay, so this person left at 0. If I ask you, what is the distance from bridge M to bridge T? What would you tell me? What is the distance from bridge M to bridge T? That's the question. What is the distance from bridge M to bridge T? 12. Good. 12 kilometers. Okay. Now, if I ask you, what is the distance from bridge T to bridge M? What would you tell me? You would tell me 12. Good. So if I ask you, what is the total distance taken? What would you tell me? You found the distance from bridge M to bridge T, yeah. And then you found the distance from bridge T to bridge M, right? So if you want the total distance, what do you do with those two? Good. Now I'm getting the correct answers in. Good. So now tell me, what is my total distance? Good. There it is. It's coming in. Some persons had that. Good. But good. That means we understand. Good. Good. Now remember, I see someone put 12 times 12. Remember, we are finding total means to add. We found it by finding the total distance from bridge. We found it by finding the distance from M to T and then from T back to M. That's the method we're using. Now, okay, this page is not so nicely printed. I will look for another one. But this says Sarah left to go to the clinic. The graph shows her journey. So we're going to work on this one. The good thing is you can see the graph. So let's start, please. We're going to work on this sheet. First question, what time did Sarah leave? Remember, before you start anything, complete the graph. Those persons who can, this is on Student Shared. You would click on the subject Mathematics. This is 2007. If I find a better quality one, I would switch out. So the question says, the travel graph below shows Mr. Brown's drive from Wallace-Town to Rosetown. He leaves Wallace-Town at 1300 hours and stopped for lunch on his way to Rosetown. How far is Wallace-Town from Rosetown? And you can see that there's no return. There's no return back. There's just this person left from Wallace-Town and they went to Rosetown. So they probably was visiting Wallace-Town and went home to Rosetown. This is a nice, easy. So let's go ahead. Let me draw the time, please. So So this is how I remember army time. With 3, that would be one, 2, 3, 4, 5, 7, 8, 9, 10. Okay. Okay, so you're gonna answer the 4 questions. And you can send them in the chat for me. I'll give everyone enough time to answer them, and then I will work it on the screen. Oh, okay, someone didn't finish. Now be careful with this now. Be very careful with this. There's no line here, but if I look, that looks like the half mark. So you have to complete that. So be careful of that. So if this is going up by 2, 4, 6, 8, that means that Wallace Town will be 0, 2, between here, 10, 20, 30, 40, 50, 60, 70, 80, 90. Okay, good. I see the first answer. Next, it says, how long did the journey take? This isn't much of a journey, but I think the hard part comes in with you converting from army time. That's it. How long did the journey take? How long means distance. No, time. How far means distance. How long means time. How long did the journey take? And you see the time didn't start at 0. It started at 1300 hours, which represents 1 o'clock. Remember when we did the average speed? Remember we found the distance, we added all the distance together, and then we divided by the time taken. Okay, I'll give you a few more minutes. Okay, so that's number one. We got the answer for number one. How far is Wallace-Town from Rosetown? So we all agree that it's 70 kilometers. Okay, how long did the journey take? I see a few persons gave me the answers there. You need some more time. Okay, B. How long did the journey take? How long talks about time. It didn't say anything about exclude stops. All it said was how long did the journey take? How many hours? 2, 3, 4. Everyone got that? How many hours did the journey take? Count the journey again for me, please. And tell me how many hours did the journey take? From 13 to 14, from 14 to 15, from 15 to 16, from 16 to 17. Okay, let's be clear on this. You have to move in order for you to count the journey. So you cannot say, okay, 13 is 1 hour. That's no hours because you didn't move. So it will be this. Remember, how long talks about the boxes. 1, 2, 3, 4. Thank you, Brittany. 4. You're not going to say 13 is 1, 14 is 1, 15 is 1, 16 is 1, 17. No. Then you would have gotten 5. But it's the boxes. 1, 2, 3, 4. Okay. Next, how long did Mr. Brown stop for lunch? How long did Mr. Brown stop for lunch? That's a giveaway. Yeah, everyone got that. 1 hour. Everyone got that. Good. And then the next one says, calculate the average speed of the journey. Calculate the average speed of the journey. Okay, I want to hear from some of you. When we did the average speed, I put this formula here. I think the last question asked us for distance. It didn't ask us to calculate the average speed, but when we did the average speed, I put that formula up there. Now I see they saw some different answers, and I just want to make sure that everyone used the formula. I'm going to go back to that sheet. Hold on, I'm trying to get up there. The sheet here. Remember with the average speed, what did we do? We calculate all the distance, the movement, and we divided it by the total time. So from here to here, we got 20. From this movement to this movement, we got 10. And from this movement to return, we got 30, which gave us 60 km. Then we divided it by the total hours. Okay, so let's go back to that sheet. And this will be our last question. We'll end right here. Oh, okay. So now, can someone tell me what is the total distance? What is the total distance? Remember, when we're calculating the average speed, we only want the movement. How fast is he going? When he sit here, he ain't moving. He's staying right there. No movement is happening there. So, give me the distance. BST. So speed is equal to distance over time. So from here to here, what's the distance? Yes. So from here to here, 40. It's 20 and 2 and 20 is 40. Okay, from here to here, how much is that? Remember now, in the middle here it's 10, so be careful of that. Which would be 70. So this would be another 20 and then a 10, right? So this is 20 and then a 10, which would be 30. Good, so when I add them together, what do I have? Remember, we calculated speed. Speed deals with movement. Okay, 70 divided by, what's my time? How many hours we got? Okay, 1, 2, 3, 4. When we divide that, what do we have? $70 km divided by 4 hours is what? Let's divide. Four goes into 7. 1 times 4. Subtract. 4 goes into 30. 7 times 4 is 28. Subtract. 0.0. Bring that down. This would be 0.5. So the average speed for this entire journey would be 17.5 kilomiles per hour. Good. All right, good. Okay, so we are going to stop there today. Classes will be again on next week, Saturday. If you have any past BJC booklets, just practice all of these questions. This is how. Okay, good job, Evernique Cobra. She said that. You just practice these past questions. It helps you when it's time for the exam. You would already have a feel of the type of questioning and the question that comes. Because the exam doesn't change, just the numbers. But the concept remains the same.